Good morning, students. I welcome you all for today's session. So, in today's session, we'll be learning about the relationship between circumferential strain, longitudinal strain, and volumetric strain. Right? So, all these are change in dimensions. Whenever I call strain, so we know that strain is defined as change in dimension to the original dimension. So, I'm going to consider the change in diameter, the change in length, which ultimately causes the change in volume in this particular case. Right, so the sentences what I have noted here are very important. So let us go through and analyze these. The diameter, length, and volume of the cylindrical pressure vessel increases when it is subjected to an internal pressure P. Thus, from generalized Hooke's law, okay, I have written some statement. This is important. The diameter, length, and volume of cylindrical pressure vessel increases when it is subjected to an internal pressure P. Right? So what he is trying to tell here is, suppose I am having cylinder, something of this sort. Let me connect it from this point. Something of this sort. There is a cylinder, and say its length is L. So length of the cylinder is L. Just an example. And say it is filled with some fluid. It is filled with some fluid here, and the pressure of that fluid is P. Now, this fluid, which is inside this cylindrical pressure vessel, will be exerting a pressure, like this, right? It will be exerting pressure like this onto the cylindrical wall. So this pressure will be acting orthogonally, or you can call that the pressure will be acting perpendicularly to the surface of the cylinder. And because of this pressure, what happens is its diameter will increase because of the pressure which is acting here. The diameter will increase. Diameter will increase. Right? So diameter will increase. Similarly, in this case, the pressure is acting onto the circumference, and since the fluid is stored here at high pressure, pressure will also act along this direction. Along this direction. When pressure is acting along this direction, which is nothing but a direction of the length, so length will also increase. So when diameter is increasing, length is increasing. So this is also increasing, and the diameter is also increasing. Ultimately, volume should also increase. Volume should also increase. Right? So the diameter, length, and volume of the cylindrical pressure vessel increases when it is subjected to an internal pressure P. That internal pressure P I have shown it here. Thus, from generalized Hooke's law, now now I am going to write an expression for circumferential strain. So circumferential strain expression is written by sigma C by E minus sigma L by ME. Right? So sigma C is circumferential stress divided by E is Young's modulus minus sigma L by ME. So here in this case, in the second term, 1 by M is called as Poisson's ratio. 1 by M is called as Poisson's ratio, and you are having this negative sign because whenever you are writing an expression for circumferential strain, so here loading direction will be along the circumference, so sigma C by E will be positive, whereas along the longitudinal axis, what is happening in the other direction, the strain will be negative. We have already studied the circumferential strain, right? So according to generalized Hooke's law, along the loading direction, it will be positive. In the other dimension, the length or the parameter is going to decrease. Apart from loading direction, in the other two directions, the dimensions are going to reduce, and that is the reason you are having this negative sign. That is the reason you are having this negative sign. So we are knowing the value of sigma c. What is the value of sigma c? Value of sigma c is PD divided by 2t. PD divided by 2t, and this 1 by e I kept it as it is in the denominator. Then you are having minus sign, so I have put the minus sign over here. Next, value of sigma L is PD divided by 4t. PD divided by 4t, and 1 by m I have kept it as it is, and 1 by e also I have kept it as it is. Right? Now we'll just go through and think what is common in between these two terms. Now here, if you just try to take out the common terms here in between these two terms, we just try to check out what are the common terms. So PD divided by 2TE can be taken as a common term. PD divided by 2TE. So if you are taking PD divided by 2TE as a common term, what will be remaining is 1 minus 1 divided by 2m. Okay, this is the common term. So what is the concept here? If I multiply these two terms, if I multiply the first term and the common term, then I should be getting this value. And if I multiply this and this term, I should be getting this value. Okay, so this is the logic of taking things into consideration, common things into consideration. So PD divided by 2T is common. So what is left out is 1 minus 1 divided by 2m. Okay, so this is the expression for circumferential strain. So we also know that circumferential strain is caused whenever there is change in diameter. So we know that epsilon c is equal to change in diameter to original diameter. Epsilon c is given by change in diameter to original diameter. So if I'm interested in change in diameter, I will be cross multiplying these two things. So if I cross multiply these two things, I'll be getting delta d is equal to epsilon c into d. Right? So these two expressions are important for us. This expression and this expression are important. Next, so that is regarding circumferential strains. So similarly, we need to study regarding longitudinal strains. So longitudinal strain is given by sigma L by E minus sigma C by ME. I have missed out, pardon me. So you should write it here, sigma C. So this is sigma C by ME. So value of sigma L is once again PD by 4T. 1 by E I have kept it as it is, minus sign as it is. Value of sigma C is PD divided by 2T. So 1 by ME I have kept it as it is. Now if you just check out these two terms, what are common here? I'll be taking PD divided by 4T E as a common term. So in order to accomplish this, what I do, this second term is multiplied by 2 and divided by 2. Here multiplying and dividing by 2, the value is going to remain same. However, it will be helpful for me to take the common term as PD divided by 4TE. So whenever you are taking PD divided by 4TE as common, so remaining thing left out in the bracket will be 1 minus 2 by m. Once again, the logic is if you are multiplying these two terms, then you should get this one. And if you are multiplying these two terms, you should be getting this value, right? So that is the logic why we take common and how we are going to write things within the bracket. So this is the expression for longitudinal strain, and we all know that longitudinal strain is caused because of change in length. So longitudinal strain is given by change in length divided by original length. So expression for change in length will be epsilon L into L. So these two are once again important expressions for us. Once if you are done with circumferential strain and longitudinal strain, now we'll be correlating things with volumetric strain. Proceeding further, volume of the cylinder is given by pi by 4 d square L. Pi by 4 d square L. So differentiating this above equation we get. So now I am going to make use of partial differentiation. I'm going to make use of partial differentiation. Now in this case I am going to make use of u into v rule. U into v rule. U into v rule. So what is u into v rule? Pi by 4 d square I kept it as it is. Pi by 4 d square I kept it as it is. Differentiation of L is delta L plus pi by 4 as it is. Pi by 4 L as it is. Pi by 4 L as it is. And what is differentiation of d square? Differentiation of d square is 2d into delta d. Right, so once I have taken L as a constant and once I have taken D as a constant, so it is partial differentiation. Right, so V has become delta V or dV. So divide the entire equation by V is equal to pi by 4 d square L. If we are dividing the entire equation by V is equal to pi by 4 d square L, then in this case it is delta V by V. Now here pi by 4 and pi by 4 are getting cancelled, d square and d square are getting cancelled, pi by 4 and pi by 4 is getting cancelled, L and L are getting cancelled, 1d and d is getting cancelled. So if we just check out what is remaining here, so it is important for us. So in this case it is delta L by L. It is delta L by L. Delta L by L is nothing but longitudinal strain. And in this case what is remaining is delta D by D and 2. So it is 2. 2 I kept it as it is. Delta D by D is nothing but epsilon C. So the relation is volumetric strain, delta V by V or dV by V is volumetric strain. So volumetric strain is equal to longitudinal strain plus 2 times circumferential strain. Okay, so this is an important expression which I have derived and this I'll be making use while I'll be solving the numeric. So proceeding further one step ahead, I'll be calculating one more step here. So change in volume in this case is given by change in volume in this case is given by. So if you just check out dV by V is equal to this expression, I already derived it. So if I am in need of change in volume, I am in need of change in volume. So dV I'll keep it on one side and V I'll take it here onto the right hand side. Now therefore change in volume is equal to this value epsilon L is given by epsilon L is given by this term Pd divided by 4Te 1 minus 2 by m. This I already derived. Yes. Next I am having epsilon C. 2 I have kept it as it is. Epsilon C value is once again given by the expression which I have derived previously. So that is this one. Pd divided by 2Te 1 minus 1 divided by 2m into V I have kept it as it is. Into V I have kept it as it is. So this V I have kept here as it is. Right now what I'll be doing here is, so these two and these two are getting cancelled. So these two are getting cancelled directly. Now I'll be multiplying these and opening the brackets. I'll be just multiplying these two terms and these two terms. Right. So PD divided by 4TE, PD divided by 4TE. I got this as first time because when you are multiplying these two terms, so I'll be getting the result as PD divided by 4TE. Minus sign intermediate, you are having minus sign, so you keep the minus sign here. If you are multiplying these two terms, so I'll be getting PD divided by 2TEM. So 2 ones are 2 twos are. Here you are having some cancellation or simplification. Resulting term is PD divided by 2TEM with a negative sign. Once again, I'll be opening the bracket, multiply these two terms. So it will be PD divided by TE because 2 and 2 got cancelled. Minus sign as it is. Multiply these two terms. So it is PD divided by 2mTe. Once again, intermediate minus n as it is, and you keep V as it is. So among these terms, if I just check out, among all these terms, if I just check out, then what can be the common thing? PD divided by 4TE can be taken as common. PD divided by 4TE can be taken as common. Right? So what I can do here is PD divided by 4TE, I have taken it as a common term. PD divided by 4TE, I have taken it as a common term. So I have taken common from this expression. Right? So in the bracket, I'll be getting 1. Here in the second case, it will be minus 2 by m. Third case, it will be plus 4. And fourth case, with a negative sign, it will be minus 2 by m. And this V, I kept it as it is. Right? So PD divided by 4TE, so it is 4 plus 1, I'll be getting 5 minus 2 by m and minus 2 by m. So this expression and this expression, those get added up. So it is minus 4 by m into V as it. So this is the expression for a volume, change in volume in terms of circumferential strain as well as longitudinal strain. Once again, this formula is also important. I'll be using these formulas once I start with the numericals. Right, so that's it for today's session. Have a good day. Take care. Bye bye.